Organizing committee for giving me this opportunity to show you what we mean for collective analysis. Just a second, okay. Okay. Maybe I should. Okay. Thank you. In this presentation, I will spend a few minutes just to introduce food analysis by NMR spectroscopy, and then what we mean for community-built analytical systems. And I will show you just a few examples of our studies, explaining what we are doing now with these systems. When we talk about food analysis, we must face many questions that are difficult to answer because many factors changes the rules, for instance legislation, but also climate changes, practical agricultural practices, human practices. Many factors affect the composition of the food. So to have the answer for this list of questions is very complicated, but NMR, I don't need to convince you that NMR is a powerful tool because combined allows for simultaneous identification and the quantification of molecules and samples in a complex mixture, combining two analytical approaches, the traditional targeted approach and the new non-targeted approach. Combining these approaches, you can have many information on the samples under investigation, for instance, environment, where it was grown, typicality, farming practices, and many other factors. What we need to give answer in this, to these questions is a representative collection of authentic samples, provided of identification data, the so-called metadata, and NMR spectra related to this sample. And how does it work? You need, I don't understand, sorry for that. Okay.
Not the top.
I'm wrong in,
yeah.
I push on the wrong. We must start with collection of authentic sample, then set up the NMR experiment and validate it. Then run NMR experiment of authentic sample and collect all the data, metadata and the NMR data in a suitable database. This is the analytical part, and then we move to the second part that makes informatic science the protagonist, where we train and validate classifiers, and we adapt software application to make the data and results available for everybody. And then we can move in the final part, the routine part, where unknown samples are submitted to the analysis following the same protocol that we adapted in the part 1, and then we get the information on quantification and identification. We can apply three different schemes for this analysis. The most popular one is the one-to-one scheme, where all the samples on different products are analyzed by a single NMR spectrometer in one lab. Then the lab creates the database, the algorithms, the classification algorithms, and use them to identify unknown samples. This is the most popular one, but we are working in the development of a one-to-n scheme, where one spectrometer collects all the samples, analyze the samples, create the database, and create the classifiers, and then many laboratories can provide the spectra of unknown samples, and the algorithm give the answer to many laboratories. But the third scheme, end-to-end scheme, is is our target in future studies. Consists in the analysis by many spectrometers that feed a database. Then the database is used for classification of algorithms, and many spectrometers can use can analyze the same products and use the classifier to identify unknown samples. Now I will present our results on one-to-n scheme. We developed many projects in this with this scheme, and you can visit our website, where we have 3 different applications: one for tomatoes, grapes, and wheat. The other one, Iperdurum, the most recent, is an application for wheat, pasta, and bread, and the other one only IntelliTrace only for wheat. To do that, we need to demonstrate that the same sample analyzed by different NMR spectrometers give the same results in terms of relative intensity, the intensity of a target signal and intensity of a reference signal. And this was demonstrated by us in the last years, and in 2020 we published 3 papers demonstrating that. And now I will show you only a little part of these studies. Just the part that consists in the validation of the one-to-n scheme. We organized 2 different interlaboratory comparisons. One using grapes as samples, and the other one, the recent one, with wheat and pasta. And the approach in these studies, one NMR spectrometer, our spectrometer, produced the spectra for training, and the other spectrometers analyzed the same samples and were used as a test. In the comparison with grape, we collected spectra from 66 spectrometers. Here you have the list of the magnetic field availables and the manufacturers. And this is the geographical distribution of the lab. And what we did was to compare 2 tubes with different grape juices. And in that occasion, we prepared also additional tube with a spike solution that were used for quantification of some metabolites: sugar, glucose, fructose, alanine, arginine. And now I will show you a part of the quantification. We developed calibration lines for these metabolites I just mentioned. And the important information I want to give you in this occasion is that when data are processed by many users, one per spectrometer, we collected calibration lines that have these distributions. In principle, if the ratio between one signal and the reference signal should be the same for each spectrum, independently on the spectrometers, then also the calibration line should be equivalent for each laboratory. But this was the result collected with data processed by the lab. But when the same data were processed only by one person, Stefano Todisco in our lab, the calibration line were most I outlined the number of spectrometers processed. Very nice guy.
Is he still recuperating?
Sorry?
Is he still on holiday to recuperate himself?
You will understand after. Okay, the distribution, so the same raw data processed by only one operator give a different results in terms of coincidence of lines. We applied a statistical filter to select coincident lines and to remove outliers. These steps, the steps of linearity, slope, intercept were selected and then the lines that didn't respect the requirement were removed. Then we tried with the parallelism test and then coincident test. We obtained two sets of lines and we calculated the average calibration line. So a community-built calibration line, we say. And we applied these lines to quantify some metabolites using 7 different signals. Here you see the concentration calculated with the coincident lines, so the lines remaining after the last filter, and also with parallel lines. So as you can see, if you compare with the reference concentration, you see that the results are quite comparable. So the quantification with a community-built calibration line is possible. Then we passed to the non-targeted part of the study, comparison of tubes X and Y that were very similar in the concentration of glucose and fructose, the most intense signal in the spectra. So poor discrimination was expected by this comparison, but and we have created the database with 50 samples of one cultivar and 50 samples of the other cultivars by our spectrometers. And we use the spectra coming from the 66 spectrometers, 5 repetitions per sample, as blind samples. And we tried to see the answer of the classifier, and only 3 spectra were considered, predicted in a wrong way. So we can be satisfied of these results. Now, moving to the second comparison, we collected the spectra from 49 spectrometers. Here you have the distribution, and in this occasion we started to see what happens with benchtop NMR. Only 3, but just to start is important for us. And this is the distribution. Again, European lab are more participate more than the other lab because of easiness in relationship. Here we have 1,600 spectra, and I will show you some preliminary results because we finished to collect results in February. So these are preliminary results. Well, I will compare 2 different tubes of pasta with different cultivars. Tube C is the same sample of tube B, but without TSP as an internal reference. And the same was applied for wheat. And again, when you use a spectra processed by many operators, you have a loss of 70% of spectra because they could not be read because of wrong file format. So we lost at the beginning 17% of spectra, and after you can see many outliers that if you remove these outliers, PCA give you this new distribution where you can see that the tube A is discriminated with respect to B and C, which are the same sample, but the only difference is TSP. In this elaboration, TSP was removed from the statistics, so the coincidence between the green and blue sample is okay, was in our program, and the discrimination is better. Of course, many outliers are contained in this evaluation, but we can say that we lose 27% of spectra. So 1/3 of spectra produced were not useful for the statistical evaluation. But again, when Stefano is in holiday now, but Maria replaced him. when Maria processed the spectra, the same raw data, we lost only 5% of the spectra. So this is a good result. And you can see here the quantity of the outliers is reduced. So this is a good, promising result for classification, but I cannot give you more information at date. Just the final results, the semi-quantitative part, because we started to quantify beta in the sample. At the moment, we have only data of the intensity ratio, and we can see that the CV percent is encouraging, is a promising value both for wheat and for pasta. And this is the number of laboratories that are in the Gaussian distribution. The yellow and red one are out, but this is the performance with data processed by many users. We don't know yet the performance when when Maria will work for everybody. Next step. Maria will process the spectra again, will extract information, and will give us in a future conference the quantification results of betaine, calculated by internal standard TSP and external standard, because we provided a tube only with the standard TSP, betaine, DMSO2, and fructose. We will process the data with 4 different software, TopSpin, Amix, MNova, and ACD Lab, and we will see the difference in the performance of the software. And we will try to the same scheme for the grape that I presented for the grape. So this is to say that end-to-end scheme, in my opinion, is going to be real. We need just to adapt some correction in our studies, but the important message to take home is that harmonization of data processing is required. Everybody will need to be followed the same procedures, and this requires a very big work, collective work. Okay, let me thank the team that helped me in doing these studies, and most important, the laboratories participating to the comparison. At date, we are over 150 labs in the four interlaboratory comparison that we organized, and of course, thank you for your kind attention.
Thank you very much. And thank you to you both NMR people, Maria, and what was the name?
Maria and Stefano.
Stefano, who did all the measurements. Are there questions? Yeah.
Thank you for this talk.
Can you stand up, please?
Yeah, thank you for this talk. Very interesting. I was wondering, you talked about harmonization of the data. What about harmonization of sample preparation? Did you supply the labs with the samples already prepared by you, or?
Yeah.
How was this?
The sample was prepared by us with Sample Pro, the sample preparing from Bruker. The procedure was automatic, and we decided to prepare the same sample and distribute in the different tubes because now we want to appreciate the error coming from the experiment, from the spectrometer and from the processing of the spectra. Of course, after we will add the error in the, deriving from the sample preparation. But that error is a normal error that you meet for every method. That's why we are focusing now our attention on the error coming from the NMR spectroscopy. Thank you.
You had a question?
Thank you. So thanks, Peter. I have a question too. So as you said on your last slide, the huge importance is getting the proficiency in the user community to do the processing and then later acquisition. So the question is whether you think that that you can build a proficiency to do fully manual analysis, or do you think that automated analysis has a role? Sorry, processing and analysis.
In our opinion, automation is welcome because we should remove the human error because we see that human error has a big role in the error budget. So hopefully, if we are able to automatize all the workflow, should be very nice. We create automation in the sample preparation. We created automation in the calculation after integration. But before integration of the signal, we are now working on with manual work. And hopefully, if we replace human operators with software, it should be very nice. But we have seen differences in the software performance. That's why we will use 4 different software just to have a look on what happens, changing the software and changing also the algorithm for integration, because we have seen that MNOVA that offer the opportunity to integrate in different ways give different results. We are very low in the error. It's not important in the error budget, but there are some effects, and we need to know these effects.
Well, I think my questions go in the same direction, coming more from the acquisition side. So did you give like parameters that should be used for the acquisition?
Yes.
For these ones? So you gave? Okay.
Yes, we gave the sample, we gave the acquisition parameters for each magnetic field. So everything was harmonized. The first part, the part of acquisition is harmonized for every magnetic field. What is not still harmonized is the processing part.
Yeah. No, so what still, I think the last week you as well presented the first part of the test, and the standard deviations that you get are still in the order from 5, for many of them are 5 to 10%, which is encouraging in a way, but if you heard from Matthias was before, we were talking about 0.2, 0.3%, right? So where he wants to get, and now we have this variation. So there must be a way, because there are, in principle, all the things that were discussed before, where to check, if you fix them, where are still the deviations, the much larger deviations coming from? That's probably the question. Then
Yeah.
What we expect now.
But the important point is to know the origin of the errors, and then we will
Exactly. Yeah. No,
and then we will make the choice.
Did you see impact of the field strength? So because, for example, this biasing, when you have like Mason separation, should have something to do as well.
Unfortunately, I could not show all the results, but the bias deriving from the magnetic field was present in a previous comparison, because integration was the integration region of the signal was fixed for all the magnetic fields. This time we changed it based on the magnetic field, and there is no bias deriving from the magnetic field.
Any further questions? Yeah? I think I will not be able to come to you, so we'll speak up.
One of the characteristics of principal component analysis is that different principal components should be uncorrelated. Now, in your PCA plots, you can see very nice correlation between the 2 principal components. So do you know what aspect of the data is causing that correlation between the 2 components?
For the last study,
For
I
both
have.
of them, there was.
I understand. We are trying to understand well, because I can say that it doesn't depend on magnetic field, and this was the first idea at the beginning. But we know that there's no dependence on the magnetic field. Today I cannot give you an answer because we have no. We are trying to understand why there is this behavior that is common. All the comparison gave this distribution, and till now we didn't spend time. Honestly, we didn't spend time to understand that distribution, because we were interested in knowing if the classifiers work independently on all the errors coming from many sources. But now that everything is almost designed, we will gain insight in that distribution. But sorry, today I cannot give you an answer.
Okay, then we continue with Mike.
Please join me.